So for a while now, I've been talking about how much I absolutely love compression fittings for any application in a 3D printer where you are required to retain the position of a Bowden tube. However, as great as these are, there are some things you need to know about them before you just go out and buy them. In terms of reliability, they are by far the best retention mechanism I have ever used. I've got over 500 hours on a single compression fitting on my 3D printer without a single issue. That is incredible. I have not gotten more than 50 hours out of a cheap pneumatic coupler before its teeth start to give way and the Bowden tube starts to wiggle. No such problems with the compression fittings. That being said, there's one tiny detail that you need to be aware of, and that detail comes down to the threads of these components. So this is a standard Mark 8 hot end. It comes on Ender 3s as well as a variety of other cheap 3D printers. And if we were to try and take our pneumatic coupler and screw it into place, it goes in just fine, not a problem. However, the moment we try and put in a compression fitting, well, I can't get in any further than here, and there is a reason for that. Just about every 3D printer component is tapered, meaning the threads on these components are not equidistant from each other from the beginning to the end of the threads. So it comes inward the further down you go. And that's why we're able to screw these components into each other, because the threads that are tapped into these components, like the hot end, are tapped in a way to reflect the threads of the components that are going into them. And the reality is, these compression fittings are not tapered. These threads are equidistant from each other from top to bottom. And because of that, if we try to screw this in, the top of the threads on a hot end start out the same, but they get tighter as they go down. And that's why we can't screw these in. However, there is a simple solution. And if you look at this plastic BMG, it used to be the same way, but now it goes in nice and easy. So let's talk about how we fix this issue. This is a tap set. These are used to create the threads inside of a component like this. And you'll notice we've got three types: taper, plug, and bottom. If we were to take these threads to visualize, you can actually see what I'm talking about. So on the left, we have a bottom plug. Those threads go pretty much all the way to the bottom and are the same. But if we look over to the right, you'll see that it's tighter down at the bottom and it gets wider as it goes up. And the middle is kind of in between those two designs. And that is why the threads on something like a Mark 8 hot end get tighter as you go down. It starts out relatively small and gets bigger as we go up. So the way to fix this is pretty simple. We take the correct size tap, and in this case it's an M10 by 1 tap. And we're going to take it and we're just going to use the bottomer tap to modify the threads so that they are all straight and flat as it goes through the entire hot end. And that will allow us to screw in our compression fittings, which have straight threads as well. So for this procedure, we are once again over at one of my favorite tools, my bench vise. This little bench vise from Harbor Freight is good for so many things with probably your 3D printer parts, because it's a small vise and has a few cutouts and everything for various things that just work, and it's a swivel vise and can kind of swivel in any direction. But what we're going to do is we're going to take our bottomer tap and we are going to modify the threads inside of this component. Now you really only get one good shot at this, so take your time, and I'm going to walk you through it because aluminum is a soft metal. So first we're going to try aligning our tools threads with the threads inside of the hot end. And we're not doing a whole bunch of forcing of anything yet. You'll know you get it when it just kind of sits in place. So what we're going to do is, once you got it sitting in place, you'll feel a little bit of resistance as you turn. That's totally normal. We're modifying threads. We are cutting into the aluminum here. So when dealing with aluminum, you do one turn, well, not even a whole turn, I'm sorry, more like a quarter turn, and then you back up a little bit. And the reason you're going to do that is because as you're cutting, the flutes in this tap are going to be collecting metal shavings. And by backing up a little bit, in other words, twisting in reverse just a tiny bit after you've gone forwards, and in other words, clockwise, that's going to allow those metal shavings to travel up these empty parts of this fluted portion of your tap. And the reason you want to do that is, if you don't, those metal shavings will build up, and it's going to ruin your tap job. So what I'm going to talk about right here, so I'm going to take this and go, and we got 180 degrees of rotation. Then we're going to back it up just a little. And then what we can do is go to our next rotation. And then we're going to back it up. And then go back to our rotation. We're going to back it up. And it's going to pay to be diligent. We're not done yet. But what we are going to do is we're going to back this all the way out. And any metal shavings that are built up on the tap or built up inside of the hot end that we are modifying, we're going to want to just kind of blow out and get it all out of there, because again, the buildup of those metal shavings are what's going to screw up your tap job. So you can use a little Q-tip to kind of get them out. And then once you've cleaned it up a bit, go ahead and get your tap set back up to a point. And once you hit that point where you're feeling resistance again, which is right here, you continue nice and gentle. Back up a little bit. Remember, aluminum is a soft metal, and these taps are very hard metal, but that also makes the taps a little brittle. And we're going to take this out again. And we're going to clean up again. Now if you look directly in the hole, you can actually see the progress we're making, because we're removing the anodized part of the threads inside the hot end, which is good. It gives us a visual indication of our progress. We've got a little bit left to go. Alright. Actually, I think our tap just hit the bottom as far as it's going to go. You don't want to force it beyond that. Okay, so this is what it looks like when you've tapped the threads. And now we're going to see if we can get our compression fitting to go in nicely. And And that goes in considerably farther than it ever did before. So I would consider that a significant win. And that is how we tap the component to take this type of coupler. So at this point, we've got the compression fitting sitting nicely in whatever component it is we've modified, but if we were to try and put the Bowden tube through, it gets stuck halfway through the compression fitting, and that's because this fitting wasn't actually designed for the 3D printing industry. This is being used from the plumbing industry. And there is a little plug on the inside right there. And all we got to do is drill that out. And to do that, we take a drill bit that is approximately the size of the diameter of the inner diameter of the compression fitting. And once we drill that out, we'll be able to push our Bowden tube through. Okay, so we're once again over back at the vise, and we take our drill bit and like that, we were able to take our Bowden tube and push it all the way through. So now we can get it set up on the hot end. So assembly now would go as such. We take the M10x1 threaded side and put it into our modified components. Get it nice and snug. Next, we take our Bowden tube, slide the compression nut over the tube. Then we take the compression ring, slide that over the tube. Then we take our Bowden tube, and this would go down to whatever is going through this hot end. So in this case, it's about going down this far. Now, on a Mark 8 hot end, you're going to have to adjust that to whatever is appropriate for your nozzle. Then we can screw this down, give it some hand tightness, and ta-da! You now have an incredibly secure hot end. This is so much better than this. This has little tiny teeth that will break because the moving of the tube going back and forth, tugging back and forth on it, will rip those teeth apart. And eventually, when that happens, you get Bowden tube slippage, and that's going to kill your performance. This has a compression ring that is snugly around the Bowden tube, and no, it does not decrease the internal diameter. What it is doing is it's wrapping itself nicely around the outer diameter so that it's nice and snug, and it's got a 360 degrees of clamping force. It's all the way around, and because of that, when you compress it, it's uniformly compressing, and that is how you get a hot end that doesn't have Bowden tube issues anymore. That's ultimately the one problem with Bowden tube setups. These things. It's not a problem anymore.